Hello, my name is William Mus. So today I'm going to train the machine learning model on how to classify the loan applications as either accepted or rejected. And now we are going to use the libraries, or we want to import the libraries as follows. The first one will use the NumPy as NP, then pandas as PD, then also matplot library as PLT. And also we are going to import the Seaborn as SNP. And also we will also import the train, test, and split from the Skyline model selection. And also we will also import the standard scaler whereby we will use the one hot encoder from the Skyline pre-processing. And also we'll also import the column transformer from the Skyline compose. We also will import the logistic regression from the Skyline. Also, we'll also import the pipeline from the Skyline. Then lastly, we'll import the accuracy score, confusion matrix, classification report, rock, AUC score, and also the rock curve from the Skyline matrix. Then, after the importations from the libraries, we'll load the dataset from the location, the sample loan location, that is from the desktop. Then also after loading the dataset, use the df.add. Then after that, we'll go to the exploratory data analysis for the loan status. Also, after that, we'll also use the Seaborn to count the plot for the loan status, whereby we use the X as the loan status and data, we use the df. Then after that, we plot the title. Then we show. Then after that, we'll go to the categorical features where we'll use the df to select the data types, where we will include the object, also the column to list. Then we'll go to the numerical features where we will select the data types, where we include the integers, which are 64, and also the float, which are 64. Then column to list. Then for that we'll print the categorical features, and also we'll print the numerical features. So loan data will be as follows. The ones will be 214 and the zeros will be 186 on the count. So they are ordered with the loan status distribution. So on our loan distribution, the count for the ones are 214. As you can see on the loan status, it is above the 200, and the zeros are 186, that is slightly below the 200. Then on the categorical features, we have the employment type, loan purpose, credit history, and guarantors. Then on the numerical features, we have the age, monthly income, loan amount, repayment defaults, membership in terms of the years, then also the loan status. Then the next one will be converted to categorical features, which include the guarantors, to columns, they will be converting the categorical column, that is in terms of parameters, to numerical features. Then on that, we'll get the dummies, which are the parameters, and drop them. The first one will be the true, then data type to be the int, that is the integer. Then we'll go to the df, that is for the head. Then df will include the employment type unique. Then we also have the arrays, which will include the self-employed, informal, unemployed, formal. Then data type will be the object. Then we go to the loan purpose unique, whereby the arrays will be as follows. We will have the farming, housing, business expansion, school fees, then the medical. That is the data type will be equal to the object. Then we'll go to the credit history, which the array will be poor, good, fair. The data type is equal to object. Then we'll get the df is equal to dot n. Then we'll go to the data df filing none. That will be equal to 0 in place of is equal to true. Then df dot n. We go to the df dot n. Then we go to the call to scale. We will call them to scale, which will include the age, monthly income, loan amount, repayment defaults, membership in terms of the years. Then we'll call to encode, where we'll have the employment type, loan purpose, then credit history. Then we go to the df, we call to scale, whereby we use the scalar to fit and also transform. Then after that we go to the preprocessor, we will column the transformer. Then on the transformers we have the numerical, which is the standard scalar that we basically call to scale. Equal to scale. Then we also use the cat as the one hot encoder. Where when we drop to first, then we call to encode. Then after that, we drop the columns, that is the loan status. We use the x as the x dot, x is equal to df dot drop to columns, that is on the loan status, and y is df the loan status. Then that will train test split. That by we divided the data set into training and testing sets, whereby we have the x train, x test, then y for train, y for test. That is train test split, that is x, comma y, test size is equal to 0.2. Then random state is equal to 42. And stratify is equal to 5. Then after that, we'll go to the logistic regression model training, whereby we use the logistic regression as the maximum integer is equal to 1000 and random state is equal to 42. Then after that, we go to the pipeline pre-processing plus logic registration, where we use the pipeline model. Then the preprocessor, we use the preprocessor and classifier. On the classifier, we'll use the logistic regression whereby the maximum integer is equal to 1000 and random state is equal to 42. Then in the model, use the model.fit whereby use the x train and y train, as you can see. Then after that, we'll use the evaluation model whereby use the y pred is equal to model.predict whereby use the x test. Then also use the y prober, which is the model for model.predict proper whereby use the x test, that is full colon comma 1. Then we'll print the accuracy whereby use the accuracy score for the y test and the y predict. Then after that we'll also use the print classification report. Okay. On that we use the y test and the y predict. The accuracy is equal to 0.5. And the classification report will be as follows. On the position for 0, we have 0.44 and 1 is 0.53. On the recall, we have for 0, we have 0.32 and 1 we have 0.65. Then F1 score, we have 0.38 for zeros and 0.58 for 1. And the support, we have 37 for 0 and 43 for the ones. And on the accuracy, micro average, we have 0.49 for both precision and recall. And on the weighted average, we have 0.49 for precision and recall 0.50. Then F1, we have 0.48 for the micro average and 0.49 for the varied average. And on the support, on the accuracy micro average, we have 80, the same as the weighted average. Then after that, we'll go to the confusion matrix. We'll go to the confusion matrix for y test and y prediction. And also the C-bonds, we have the dot it map, we'll use the CM are not equal to true, FMT is equal to D. CMP blues, X take labels N, Y. Y take labels N, Y. Then we plot the labels as predicted, and also we plot the Y labels as actual. Then we plot the title as the confusion matrix. Then we plot to show. Then after that, we'll go to the AUC, that is the log AUC score for Y test and Y probability. YFPR TPR thresholds is equal to log CAM, whereby use the Y test Y proba, then plot FPR TPR level is equal to FAUC, that is AUC cross colon dot 2F. We plot 0, 1 on that is the axis, then 0, 1 in the line scale. Then we plot the x level as false positive rate. Then also we plot the y level as true positive rate. Then also we'll plot the ROC curve. After that we'll plot the agent. Then on that, after that we'll also plot the F ROC AUC score. And after that, our confusion matrix will be as follows. We have the predicted and also the actual, as you can see on the diagram. Then after that, we also have the rock curve as can be seen on the diagram. The AUC is equal to 0.53. Then also we have the true positive rate on the y-axis. The values are also not there, and also the false rate, false positive rate are shown on the y-axis on the diagram. So that is basically the presentation which I have done briefly. Thank you very much. Nicholas. Hmm? Hmm.